Welcome to Vinex Studio. Let's start making games.
Hi and welcome to another Unity tutorial. Today we'll be seeing how to create an FPS controller using the new input system in Unity. We'll not be using the regular character controller for this. Now the inbuilt character controller of Unity has some limitations, so we'll be using a rigid body for this controller. You can check out our video on Unity's inbuilt character controller to know the limitations. Now the first step is to add the new input system package. So let's go to Window, Package Manager, and in the Unity registry packages, search for input system and install it. So once you install the input system, you'll see a pop-up. Just click on yes, and it will restart your Unity editor. So now I have an empty scene here. Let's go ahead and add an empty game object and call it as player. And let's reset the position. Okay. And then let's add a 3D capsule and let's call it player body. The reason I'm adding it as a child to the player is because if you want to switch this to a different player, you can just swap off the player body component and keep the remaining parts as it is. So select the player and click on add rigid body. Okay, let's set the mass to something like 70 and let's have a drag of 3. Now you can also make the camera as the child of the player if you're using the character controller. But in case of a rigid body, it's not recommended to actually make the camera as a child of a rigid body because there might be some shattering or some distortion in the camera view if you use it as a child of a rigid body. So it's better to have the camera separate. Let's just rename the camera to player view. Now the next thing that we have to do is just create the new input action map. So let's right click in our project window and create input actions. Let's call it FPS control. Okay. Let's double click to open it. And this is our input action editor. So let's dock it here. Okay, let's make it a little bit big. Now let's create our first action map and call it player map. Now let's create a new action. So if you don't know about the new input system, do check out our video on the input system, which explains in detail what are actions, what are action maps, and what are bindings. So let's create a new action and let's call this action as movement. Sorry, movement. And delete the binding that's already there. And in the action properties, select the action type as pass through. What pass through is, it basically allows the input to directly go to our wherever we are reading the value without making any adjustments or adding some constraints to it. And the control type is set to vector2. And once you set these two parameters, click on the plus sign on the moment and make sure you select up, down, left, right composite. If you're using an older version of input action, it might also be a 2D vector composite. Now let's set the keys for each of the sub actions. So let's select the up arrow. Now click on the path, click on listen, and let's press W. Okay, let's do the same thing for down. So for down, it's S. Okay, click on left. For left, it's A. And now let's click on right. Right, it's D. So with that, our moment action is set. Now we don't need input action for the mouse because Unity has a way to get the mouse movement using code directly without creating an action map for that. Okay, make sure you check the autosave here and it will save the changes that we have done here. So after that, just go to your FPS controller and go to your inspector window and check generate C# class and click on apply. So once you click on apply, Unity will generate a C# class with the same name as your input action. An FPS control script is created. Now let's go ahead and create our player view script first. So before that, we'll need a ground. So let's go ahead and create a 3D plane. Okay, and let's reset the position and let's scale it by 10 in the x-axis and by 10 in the z-axis. And let's move the position to -1 in the Y so that it's below the player. Okay, and let's call it ground. Let's go ahead and add some cubes also so that we'll have something to look at. And let's move them, let's duplicate, move them here, duplicate, move them here, duplicate. Yeah. So now we have some cubes in the scene and a ground and our player. So select the main camera, which is our player view now, and click on add component. Let's create a script called look control. So again, if you have made the camera as the child of the game object, if you're using a character controller, then this script will change a little because you don't have to update the position of the camera. The position will be updated automatically based on the parent's transform. You only have to control the rotation of the camera based on the input. Okay, so let's create the look control script. Let's open it in Visual Studio for editing. And we don't need these two using statements, so let's delete them. And what we need is using Unity engine dot input system. Now the things that we'll need is a player, so public game object player. Then we'll need a vector2, and it will be mouse movement. Then we need two floats, which will be x rotation and y rotation. Then we need the basic offset of the camera because if we go back to Unity and select the player view, we can see the position is not the same as player. So the player is at 0, 0, so let's reset the position. And if you go in close, you can see the camera is somewhere in the middle. The camera should be near the head of the player. So let's move it up. So it's like 0.7 in the y-axis. Okay. So now let's go back to the script. So we need this offset, which will be a float camera offset. Okay. And now in the start, we're just going to say camera offset is equal to transform dot position dot y minus player dot transform dot position dot y. So it will subtract the camera's y position from the player's y position and save it on the camera offset. Okay, now in the update, so we'll get the delta movement of the mouse, that is the change in position. So for that, you can just say mouse movement is equal to mouse dot current dot, I think it's called delta dot read value. So this will output a vector2 to the mouse movement. So the x will be your mouse moving in the horizontal and y will be your mouse moving in the up and down direction. What we have to do is we are going to say x rotation. So this will be your rotation in the x-axis. So if it is rotated in the x-axis, then the camera will be seeing up and down. So this will be basically dependent on the mouse y movement. So we are going to say mouse movement dot y multiplied by time dot delta time. Now we also need a way to control the speed at which the camera will be moving. So let's create another float and let's call it mouse sensitivity. Yeah, and let's set it to a value 50. Okay, so and let's multiply this mouse movement with mouse sensitivity. So again, the x rotation should be clamped to 90 degrees in the positive side and minus 90 in the negative side. So let's just say x rotation is equal to mathf dot clamp, and first you give the value, which is x rotation, and then you give the minimum value 90, and then you give the maximum value positive 90. So now comes the Y rotation, which will be your mouse movement dot X multiplied by time dot delta time, which will be again multiplied by mouse sensitivity. Now to set the rotation, you can just say transform dot rotation is equal to quaternion dot Euler, and then the X will be your X rotation, and in the Y it will be Y rotation, and Z will be 0. Okay. Now when you're rotating the mouse, the player also should rotate along with the mouse so that you'll be able to move in the direction you're looking at. So let's also say player dot transform dot rotation is equal to quaternion dot Euler. Now you don't want the player to be rotating in the X direction, because if you rotate it in the X direction, then the player will start tilting in the game. So the X value will be 0. Only in the Y you will have to give the Y rotation, and the Z also will be 0. So also you can also set the cursor to the middle point so that the mouse cursor is not visible in the game. So you can just say cursor dot lock state is equal to cursor lock state dot locked. So yeah, now the rotation is dealt with. Only thing is that the camera should also move with the player, which is not taken care of. So what we need to do is we need to have a vector 3, which will be the position, which will be equal to player dot transform dot position, and then the Y value of course is going to be, you have to add the Y value with the offset camera, sorry, camera offset, and then you have to set the transform dot position to equal to pos. So this way, when the player is moving, the camera will also move with it. So now your camera script is ready. You should be able to look around. So let's go back to Unity and see if the script is working. So first we need to assign a public variables, the player. Yeah. And let's keep the scene view somewhere here. Okay, so that you'll be able to see both the game and the scene view. Now if you look around, okay, something is wrong. Now I made a simple mistake here. It should be X rotation plus and not directly equal to, because it will be only the change in value. So we have to add to the X rotation. And similarly, we have to do that to the Y rotation also. Okay, now let's save the script. Let's go back to Unity. Okay, let's play the game. Okay, I think the mouse sensitivity is too high. Yeah. So the increment and decrement is depending on how you want the mouse to move. You would have seen some options like invert Y, invert X in mouse settings in most of the games. So that's because you can allow the player to select whether he wants an incremental value based on the direction he's moving the mouse or in the opposite direction. So anyway, the script is working. So let's go ahead and set the sensitivity to something like 20. Okay, and let's say this. Now it's time to move the player. So let's go back to Unity and create a player controller script. So select the player where the rigid body is connected and click on add component and call it player. Let's call it movement. Okay, and create an add. Let's open the script in Visual Studio. So we don't need these two using statements. Since we'll be using that FPS control script, you don't need to add using Unity engine.input system. So let's just go ahead and say FPS control, and we need to create an object for it. So let's call it input control, input underscore control. Okay. And we are going to need a ground. So that will be a public game object. and let's call it ground. Now then we'll need the rigid body so that we can apply force. Okay. Then we need to check if the object is grounded for the purpose of jump. So let's create a bool which will be is grounded, and then we'll need a move force which will be float move force. Let's set it to maybe our mass is around 70, so let's set it to 50,000. And we'll need a float jump force. Let's set it to somewhere around 500. Okay, what else do we need? I don't think we need anything else. So as of now, let's start. So the first thing you have to do is input control is equal to new FPS control. So you can do this in the place where you are initializing the variable, but Unity will give you an error that you cannot call a constructor of mono behavior when you're initializing it. So I'm not sure if it is an error or warning, but Unity will give it. So it's better you do it at start or the awake function. So next thing is rigid body will be get component, and let's say rigid body. And we forgot to set is grounded to true. Okay. Now we need a variable to actually get the input controls value. So let's go ahead and create a vector2. When creating the movement action in the input control, we had set the type to vector2. So that is why we are creating a vector2 here. And let's call it move. And let's set it to vector2.0. Okay. So now in the update, we're going to say move is equal to, you have to say input control dot your player map name, that is player map, and then the action name, which is movement. Then we are going to say dot read value, and the value type is going to be vector2. This will return a vector2 value based on our key press. Now to move the player, all that you have to do is rb dot add force, dot add force. You have to add a force for moving forward and a force for moving left and right. So for the forward part, the vector3 will be transform dot forward multiplied by move dot x. Okay, and that will be a force type of force. So you can set the force mode to force. Now the other force that is required to move it in the left and right direction is rb dot add force, and we are going to say transform dot right multiplied by move dot y. So basically when we press the key, that value of move will become 1 or -1 depending on what key we are pressing, and that will be multiplied by transform dot forward, and the player will directly move. The value of move dot x and transform dot forward is 1, and force of 1 is not enough to actually move the player. And what we forgot was to multiply this with your move force. Okay, so let's multiply with move force. Okay, let's go back to Unity again. So now, where are we looking? I think, yeah. Okay, if we move the player, W, S. Okay, the reason it's not moving again is we also forgot to actually enable the input system. So you have to say input control dot enable in your start. Now let's see if it is working. Oops, it is moving way too fast. Yeah, now let's try to move towards the cube. Okay, I think the X and Y is a little bit confused here. So it should be move Y here and move X here. The up and down are in the Y axis and the left and right is in the X axis. So now let's see. Yeah, we're able to move and we are moving fast enough. Yeah, that's good. And we're able to turn, we're able to look. Okay, that's nice. So the player is able to move now. Now for the jump part, we have not added any input action. So let's go back to Unity and add that first. Double click on your FPS control. Make sure autosave is added and click on the plus sign in the actions. And this will create a new action. Let's call it jump. Now in the bindings, make sure the path is set to spacebar. So click on the listen and press space. Okay. So Unity actually automatically saves this values because autosave is pressed. The jump type is set to button. So the input value that we'll be getting is float. Now let's go back to the script. And what we can say is we can create a void player movement, or we can say player move. And then let's just add this code here. So this is just for clarity. Now before we can make the player jump, we also need to check whether the player is grounded. So let's create another function called void ground check. Now there are multiple ways to check if the player is grounded. The first option is to just take the offset of the ground and the player and see if the difference in height is more than certain value, then he is not grounded, and if it is less than a certain value, then he is grounded. Now this can be tricky if your ground is an uneven surface. In that case, you will have to use a ray cast to cast a ray from the player position in the downward direction and see if it hits something, and the object that it has hit, if it is within a certain value, then the player is grounded, otherwise he is not grounded. For our case, for the case of simplicity for this tutorial, we'll just assume that the player is of height 1 and all the ground is a flat surface. So let's go ahead and check if the distance between the ground and the player is less than 1, then he is grounded, and if it is greater than 1, then he is not grounded. So we can just say if transform dot position dot y minus ground dot transform dot position dot y is greater than 1, then we can say is grounded equal to false, and else is grounded equal to true. You can also use the collision detection to check if the player is actually colliding with the ground. So that is also one option. Both raycast and collision detection are performance expensive. So if you are having a flat ground, then I'll suggest you use the offset value to check whether the player is grounded. Now that being said, in the update, you can just say ground check. So we need to check if the player is grounded. Then we'll say if is grounded. That means the player is grounded. And we're going to say input control dot player map dot jump dot read value, and the value type is float, and if that value is greater than 0, we're going to say rp dot add force. Now this time it's going to be vector3 dot up, because we are going to add the force in the upward direction multiplied by jump force. So for the sake of clarity, let's add another function called void player jump. Okay, it's player. I'm sorry. And then let's move this rigidbody.add force statement to this function. And here we can just say if it's grounded, we just call play jump. So yeah, it's done. Let's go to Unity and check if it's working. So now we are able to move around, and if we press the space bar, so yeah, the player is jumping. As you saw, the player was falling very slowly. The reason is the drag is too high when the player is in the air. So we need to change the drag value when the player is in the air. So what you can do, if the is grounded is false, then you can just say rb dot drag is equal to 0.1. If, and if it is grounded, then rb dot drag is equal to 3. So that way you'll have some friction when the player is not on the ground, and when the player is in the air, you'll have a free fall moment. So let's go back to Unity. So now if we play our game, so yeah, I can move around, I can look around. Yeah, if I try to jump mid-air, it's not working. Okay, so everything is fine. So we have created the FPS controller with the movement script. The code samples for this FPS controller is available on Vinix Studio. I'll leave the link in description so you can just directly copy paste and have your FPS controller working in minutes. So if you have any other questions, you can leave them in the comment box below. Thank you and see you in the next tutorial.
Thanks for watching. Don't forget to like, subscribe and share.